All right, so the first part of lesson 5 deals with the insulin resistance in skeletal muscle due to an increase in ectopic fat accumulation. So again, this is a reason why skeletal muscle can become insulin resistant due to obesity in your client. So this is one of the hallmarks of type 2 diabetes. And remember, ectopic fat is that term used for fat, triglycerides, free fatty acids that are stored outside of adipose tissue. So this is a review of lesson 4 in terms of insulin being used to help stimulate the insulin signaling cascade to take up glucose. So we're just going to review this. This hopefully should be a review from lesson 4, and then we're going to do the next step of what happens with in type 2 diabetes and insulin resistance. So again, just to review, we have insulin will bind to the alpha subunit of the insulin receptor. That's going to cause tyrosine autophosphorylation of the beta subunit. This causes tyrosine phosphorylation of IRS1 and 2, which causes tyrosine phosphorylation of PI3 kinase, causing serine phosphorylation of AKT, and this then will stimulate the GLUT4 transporters to move to the cell membrane, and then then they will embed, and then acting like a channel, glucose will make its way through the GLUT4 into the muscle to either be broken down immediately through glycolysis for energy or stored as glycogen through glycogenesis. All of which, though, will reduce the blood sugar. So this is what should happen in a healthy individual. However, what happens when the tissue becomes insulin resistant? Well, here's a slide that's the same slide as before, but we're going to talk about how lipid accumulation causes inflammation and blocks insulin-responsive glucose transport, leading to hyperglycemia. So here we have the insulin. The important thing is we have our insulin signaling cascade as before, but what we have now is an accumulation of lipid, that ectopic fat, that intramyocellular triglyceride, IMTG, that's now accumulated in the skeletal muscle due to insulin resistance of the adipose tissue. It's got to go somewhere. In this case now, the triglycerides and fatty acids have accumulated here in the skeletal muscle. So what happens? What's the ramifications of this lipid accumulation in the skeletal muscle? Well, you still have the insulins going to bind to the alpha subunit of the insulin receptor. This is going to cause the tyrosine phosphorylation of the beta subunit. However, because of this accumulation of lipids in the skeletal muscle, this is going to cause an upregulation of the cytokines PKC theta and TNF alpha. These are being made by that excess lipid that's accumulating there in the skeletal muscle. These are inflammatory proteins. Well, these are going to activate the protein called JNK. It's an inflammatory protein, JNK, and this inflammatory protein is going to then cause serine phosphorylation of IRS1 and 2. Remember, before to activate it, you had to have tyrosine phosphorylation. But now, JNK will activate or phosphorylate the serine amino acid on IRS1 and 2, which then prevents that tyrosine autophosphorylation of IRS1 and 2. Well, if you don't turn IRS1 and 2 on, what happens is that insulin signaling cascade will no longer be able to make its way down into PI3 kinase, into AKT, and therefore GLUT4 will never receive that signal from insulin to make its way to the cell membrane. Instead, the GLUT4 will remain here in the cell and will not make its way to the cell membrane. Therefore, there is no way for the glucose to make its way into the skeletal muscle. So glucose will remain in the blood. As a result, you have an increase in blood sugar called hyperglycemia. So this is the steps by which, because of a lipid accumulation, adipose tissue insulin resistance leads to an increase in lipid accumulation of triglycerides and fatty acids in the skeletal muscle, leading to an increase in TNF-alpha, PKC theta, which they activate the inflammatory protein junk, which causes serine phosphorylation and prevents the insulin signaling cascade to cause GLUT4 to move to the cell membrane, and therefore glucose is not able to get into the cell. Therefore, sugar or glucose remains in the blood. As a result, as it remains in the blood, that causes the pancreas to release more insulin to find some location along the skeletal muscle where lipid is not accumulated and cause the turning off of the insulin signaling cascade. So someplace like, say, next to this might still be insulin sensitive, but it requires more insulin to be secreted in order for the glucose to get into the cell. This is just the steps that we just talked about. You can review here. But again, just make sure you review. You can look over the pathway, put the pathway in your own words, check your answers, and also use Blackboard as a way to order the steps properly to practice to make sure you have a good foundation as to what is happening with insulin resistance at the skeletal muscle.